In this video, you will learn how to expand binomial expressions. A binomial expression is an expression with two terms. Some examples are shown. To multiply or expand two binomial expressions, it is useful to think in terms of something you know already, such as the area of rectangles and squares. Take the rectangle shown. The length is c plus d and the width is a plus b. To determine the area of the full rectangle, we would need to multiply a plus b by c plus d, or we could add the area of each of the smaller squares and rectangles, that is, area equals ac plus ad plus bc plus bd. So, a plus b multiplied by c plus d equals ac plus ad plus bc plus bd. It isn't efficient to draw rectangles for every binomial expansion. A more efficient method to use is called the FOIL method. F is for first terms, O for outer terms, I for inner terms and L for last terms. Let's take an example. Multiply x plus 3 by x plus 2. Multiplying the first terms gives x squared. Multiplying the outer terms gives 2x. Multiplying the inner terms gives 3x. Multiplying the last terms gives 6. Simplifying gives x squared plus 5x plus 6. Let's look at another example. Multiply x minus 7 by 6 minus x. Multiplying the first terms gives 6x. Multiplying the outer terms gives minus x squared. Multiplying the inner terms gives minus 42. Multiplying the last terms gives plus 7x. Simplifying gives 6x minus x squared minus 42 plus 7x. Collecting like terms gives minus x squared plus 13x minus 42. Let's look at another example. Multiply 3 by x plus 8 by x plus 2. Multiplying x plus 8 by x plus 2 gives x squared plus 10x plus 16. Multiplying x squared plus 10x plus 16 by 3 gives 3x squared plus 30x plus 48. If we are squaring a binomial expression, that is, we are multiplying it by itself, we can use the algebraic identity, a minus b all squared equals a squared minus 2ab plus b squared. Similarly, we can use the algebraic identity, a plus b all squared equals a squared plus 2ab plus b squared. Let's take an example. 2x minus 5 all squared. Squaring the first term gives 4x squared. Minus 2 times the first term times the second term gives minus 20x. Squaring the last term gives 25. Let's look at another example. 2x plus 7 all squared multiplied by minus 3. Using the algebraic identity, 2x plus 7 all squared gives 4x squared plus 28x plus 49. Multiplying 4x squared plus 28x plus 49 by minus 3 gives minus 12x squared minus 48x minus 147. When multiplying a binomial expression by its conjugate, we can use the difference of two squares or dots method, in which we square the second term and subtract it from the square of first term. Let's take an example. Multiply 3x plus 1 by 3x minus 1. Squaring the first term gives 9x squared. Squaring the second term gives 1. Subtracting the results from each other gives 9x squared minus 1. Let's look at one more example. Multiply 4 by 2x minus 7 by 2x plus 7. 2x minus 7 multiplied by 2x plus 7 gives 4x squared minus 49. Multiplying the results by 4 gives 16x squared minus 196. In summary, a binomial expression is an expression with two terms. For example, x plus 2, y minus 6, and d squared plus c. We can multiply two binomial expressions by using the FOIL method. In FOIL method, F stands for first, O stands for outer, I stand for inner, and L stands for last. If we have a binomial multiplied by itself, we can use the algebraic identity a minus b all squared equals a squared minus 2ab plus b squared. Similarly, we can use the algebraic identity a plus b all squared equals a squared plus 2ab plus b squared. If we are multiplying a binomial expression by its conjugate, then we can use the difference of two squares or dots method. The dots method states that a plus b times a minus b equals a squared minus b squared.